So again, solving a system of equations using the addition method. Remember, just working with a two-variable equation, it represents a line, so there can be infinite many solutions. When working with a system of equations, we're going to work with two unknowns. If there's two unknowns, then there needs to be a set of two equations. Since both equations are going to represent lines here for us, then the following things are going to be possible. The two lines could intersect, which means there's only going to be one solution. So again, this would be represented graphically as intersection point of two lines. Also, there could be no solution to the system. Graphically, that means the two lines were parallel. Thirdly, the system could have infinitely many solutions. What this means is the lines are coincident. In other words, they lie on top of each other. So the solution itself here would be the equation of the line, because it's going to represent the order pairs on that line. So again, we want to use the addition method. So the first thing is we want to be in standard form. So our equations are in standard form. The next thing is, if necessary, multiply one or both equations by numbers that cause the terms of one variable to add to zero. So what we want to do is make one of the variables add to zero. To me, if I look at this problem, I'm either trying to eliminate the x's or try to eliminate the y's. But what I want to do is do it the easiest way. Well, if this is a 2x, then this has to be a negative 2x. So my thinking is I want to multiply just the top equation by a negative 2. But remember, you got to multiply everything by negative 2. So I'm going to bring this all over here to the next side here. So this is going to be negative 2x plus a negative 6y equals negative 6. So you got to multiply everything by negative 2. The other equation is just going to come down underneath of it. So what I could do now is I can add these two equations together because it's going to eliminate one of my variables, and I'm now able to solve for y. So that's just going to give me y equals 0. So once I found one of the variables, what I want to do is go back to the beginning and substitute 0 in for y. I have to decide which equation is easier. It looks like the first equation looks easier. So I'm going to rewrite it over. X plus 3y equals 3. And I'm going to replace 0 in for y. X plus 3 times 0 equals 3. This is going to allow me to solve for x. So x plus 0 equals 3, so x equals 3. So my solutions would be x equals 3 and y equals 0. So x equals 3, y is equal to 0. As an ordered pair, that would be 3, 0 would be the point of intersection. So a lot of times this is described as consistent and independent. It's a fancy way of describing this system. So addition method is not bad at all if it's already in standard form.